Hello students, my name is Professor Muhammad Asim and we are doing AddMath. AddMath for IGCSE students which have syllabus code 0606 and for CIEO level students which have syllabus code 4037. So both kind of students can get equal benefit from this course. Students, in last lecture we started exercise 12.3 from chapter number 12 and the topic of this exercise is differentiate the given question with the help of product rule. What is product rule? If we have two functions u and v, then the derivative of this function is first function multiplied by the derivative of second function plus second function multiplied by the derivative of first function. In last lecture we did question number 1 all parts. Today we are going to do word problems of this exercise. Let's start question number 2. But before I start exercise 12.3 question number 2, I would suggest all those students who are watching my lecture first time, kindly go to my playlist. There is a folder name is AddMath. Watch previous lecture of this exercise and previous exercise of chapter number 12. After watching previous lectures, you will have good command on this topic. Now let's start question number 2. Find the gradient of the curve y is equals to x square into x plus 2 at the point 2, 8. So question number 2, we have a function y is equals to x square dot means multiply x plus 2. What is the formula of the derivative of product of two functions? U dot v is equals to u multiplied by derivative of v plus v multiplied by the derivative of u. So gradient of the function means gradient of the curve means to find the derivative. We have talked about the word gradient in detail in previous two exercises 12.1 and 12.2. Now dy by dx is equals to the first function is x square dot the derivative of the second function 1 upon 2 power right first, subtract 1 from the power, that is 1 upon 2 minus 1 is minus 1 upon 2 dot means multiply the derivative of the function means under the power is x plus 2, the derivative of x plus 2 is 1 and the derivative of 2 is 0. So u time derivative of v plus v is x plus 2 square root multiply by the derivative of u. The derivative of u is the derivative of x square. The derivative of x square is 2x. Now this is the gradient. What is the requirement? The requirement is to find the gradient at the point 2, 8. It means we have to put 2 where we see x in the answer and we have to put 8 where we see y. So there is no y, so we just put 2. X square means 2 square. 1 upon 2. X means 2. So 2 plus 2 minus 1 upon 2 plus x means 2. 2 plus 2 dot 2 multiplied by x means 2. 2 square is 4 dot 1 upon 2. 2 plus 2 is 4 and this minus 1 upon 2 should become plus 1 upon 2. Plus 2 plus 2 is 4 root dot 2 to the 4. is equals to 2 to the 4, 2 dot 1 upon 4 power 1 upon 2 means 4 square root, that is 2, plus 4 root is 2 dot 4. 2 cancel by 2, that is 1, plus 2 4s are 8. 8 plus 1 is 9. So the gradient of the curve y is equals to x square root x plus 2 at the point 28 is 9. So our answer is 9. Hope you understand this question. Move to question number 3. Question number 3 is find the gradient of the curve y is equals to x minus 1 cube x plus 3 square at the point where x is equals to 2. Again, we have to use u into v formula. So this is u and this is v. So dy by dx u time x minus 1 cube time the derivative of v, that is 2 into x plus 3. 2 minus 1 is 1 and the derivative of x plus 3 is 1, so no need to multiply by 1, plus v time x plus 3 square dot the derivative of u, that is 3 x minus 1. 3 minus 1 is 2 and multiply by the derivative of the function, that is the derivative of x minus 1. So x minus 1 derivative is 1, so no need to multiply. Now we have to find dy by dx at x is equals to 2. So put 2 where you see x. So 2 minus 1 cube dot 2 into 2 plus 3 plus 2 plus 3 square dot 3 2 minus 1 square. So 2 minus 1 is 1, 1 cube is 1 dot 2, 2 plus 3 is 5. Kindly keep in mind dot means multiply. 2 plus 3 is 5 square dot 3. 2 minus 1 is 1, 1 square is 1. So 5 2s are 10, 10 1s are 10. 5 square is 25, 25 3s are 75, 75 1s are 75. 75 plus 10 is 85. So 85 is our final answer. Therefore, the gradient of the curve x minus y whole cube into x plus 3 whole square at the point where x is equals to 2 is 85. Now move to question number 4. Question number 4 is find the gradient of the curve y is equals to x plus 2 x minus 5 square at the point where the curve meet the x-axis. It is very easy. First we have to find the value where the curve meet the x-axis. So y when the curve meet the x-axis, the value of y must be 0 is equals to x plus 2 x minus 5 whole square. This implies that x plus 2 is equals to 0, x minus 5 whole square is equals to 0. This implies that x is equals to minus 2 and x is equals to 5. So these are 2 points where the curve meet the x-axis. Now find the derivative of this function by using the formula u into v. Here u is x plus 2 and v is x minus 5 whole square. So u time derivative of v, that is 2 into x minus 5, plus v time derivative of u, that is the derivative of x plus 2 is 1. Now satisfy both the values of x one by one. dy by dx at x is equals to minus 2. So x is minus 2 plus 2 into 2 into minus 2 minus 5 plus minus 2 minus 5 whole square dot 1. Minus 2 plus 2 is 0 and the whole of this thing is 0 because something multiplied by 0 is always 0. Plus minus 2 minus 5 is minus 7. Minus 7 square is 49. So first value of the gradient is 49. Now we have to find the second value by putting the value of x is equals to 5. So dy by dx at x is equals to 5 is equals to, now put x is equals to 5 in this answer. So 5 plus 2 whole square dot 2 dot 5 minus 5 plus 5 minus 5 whole square dot 1. 5 plus 2 is 7 square into 2 into 5 minus 5, it means 0, plus 5 minus 5, it means 0, and something multiplied by 0 is always 0. Hence we have two answers. We have two answers of gradient of the curve. One is 49 and other is 0. These are the final answer, 49 and 0. Now move to question number 5. Question number 5 is, find the x coordinate of the point on the curve y is equals to 2x minus 3 whole cube dot x plus 2 power 4. It is very easy. First we have to find the gradient. It means we have to find the derivative. dy by dx, the first function is u and the second function is v. So u time derivative of v plus v time the derivative of u, power right first, subtract 1 from the power, that is 2, multiply by the derivative of the function. The function is 2x minus 3, the derivative of 2x minus 3 is 2. So this is 100% the derivative. Now the question is, Find the x coordinate of the point on the curve where the gradient is 0. So replace this gradient by 0. Now what is our answer of the derivative? 4 x plus 2 whole cube 2x minus 3 whole cube plus 3 2s are 6 x plus 2 4 2x minus 3 square. We can take common from the both is x plus 2 whole cube and 2x minus 3 whole square, along with 4 and 6 common is 2. So 2 multiplied by x plus 2 whole cube 2x minus 3 whole square bracket 2 2s are 2 2s are 4. So 2 into 2x minus 3 plus 2 3s are 6 x plus 2. This is our common. And it is equals to 0. This implies that 2 into x plus 2 cube 2x minus 3 square 2 2s are 2 2s are 4x 2 3s are 6 3 into x 3x 3 2s are 6 is equals to 0. So this implies that this 2 is multiply over here, this should divide by 0, so it will be vanish. Then x plus 2 whole cube is equals to 0 and 2x minus 3 whole square is equals to 0 and 6 cancel by 6, 3x plus 4x is 7x is equals to 0. Now taking one by one, x plus 2 whole cube is equals to 0. 3 must be goes to other side, it will vanish and x is equals to minus 2. Similarly 2 is the square is goes to other side, it will vanish. So 2x minus 3 is equals to 0. Then x is equals to minus 3 upon 2 becomes plus 3 upon 2. X is equals to 1.5. And 7x0 means x is equals to 0 because 7 must be divided on other side. Hence our answer is the x coordinate is minus 2, 0 and 1.5. Very interesting question and very important question according to examination point of view. Move to next question, question number 6. Find the x coordinate of the point on the curve y is equals to x plus 3 4 minus x root where the gradient is 0. The same question, question number 5 and question number 6, the same question, but values are different. So this is u and this is v. First we have to find the gradient, that is the derivative. U time derivative of v, 1 upon 2 minus 1 is minus 1 upon 2 dot the derivative of the function minus 1 plus v time derivative of u, that is 1. So x plus 3 and multiply minus 1 divided by 2 into 4 minus x power 1 upon 2. 4 minus x must be 4 minus x and root means 1 upon 2. Taking the LCM, sorry for this, LCM is 2 multiplied by 4 minus x half. 2 into 4 minus x half, 2 into 4 minus x half cancel, minus 1 into x minus 1 into 3 is minus 3 plus multiply this 2 whole 4 minus x by 4 minus x, it will be 2 into 4 minus x half, 4 minus x half, half plus half is 1, so only 4 minus x is equals to minus x minus 3, 2 4 is 8, 2 into x 2x upon 2 into 4 minus x power half. Minus 2x minus x minus 3x, 8 plus 3, 8 minus 3 is 5 upon 2 into 4 minus x to the power 5. We have to find the value where the gradient is 0, so replace dy by dx by 0. This whole 2 into 4 minus x power half multiplied by 0, the answer is 0. So only is minus 3x plus 5 is equals to 0. Shift this plus 5 on other side. It will be minus 5 minus cancel by minus x is equals to 5 upon 3. Or you may write in terms of mixed number, the answer of x is 1 whole 2 upon 3. 3 ones are 3, 3 plus 2 5, the same answer, but this is the requirement of the question. So this is the value of x. So hope you enjoy the whole exercise. That's it. This is the last question of exercise 12.3. So very easy till now from 12.1 to 12.3. Today we have finished 12.3. We did all questions. What next? Exercise 12.4. Exercise 12.3 based on the product rule, and 12.4 is based on the quotient rule. What is quotient rule? Very easy. I will give you complete detail of this formula, and again very easy exercise, very easy. You will be witness. So no issue. In next lecture we will start exercise 12.4. That's it, student. We did today in today's class. Kindly do subscribe my channel. Whenever you subscribe, don't forget to press the bell icon button so that when I upload my videos you will get the notification. Kindly share my videos as many as you can. Okay students, good luck for next lecture.